In this video, we're going to be looking at solving radical equations, and you have to be able to do that to answer these two questions. Also, notice that the instructions say to solve algebraically. That means you're not to use a graphing calculator. So if your math teacher gives you homework and says to solve it algebraically and you draw a picture of a graph, you can expect to get 0 points, I would imagine. So let's look at this one first. So suppose f is this function, and we want to find if there's any x-intercepts without using a calculator. And then were there any extraneous solutions for x? A calculator will not show you that. You have to do it algebraically to be able to answer that question. All right, so the first thing we need to recognize is our solution to get the x-intercept. We have to put f of x equal to 0 and solve for x. Now, there are a lot of students who get that wrong and who think they just have to solve that. So putting x equal to 0. That is how you get the y-intercept. But we've been asked here to solve for the x-intercept. So this is a different matter entirely. So we do not put x equal to 0. So we want to solve for x. Okay, so if f of x equals 0, well, here's my equation. So f of x equal to 0 is the same as the equation for f of x being equal to 0. Now I want to isolate this radical. So I want to get everything else to the other side. So I'm going to add x to both sides, and I'm going to subtract 1 from both sides. And so I'm going to have that's equal to x minus 1. Now I have a radical equation that I can solve. And I'm going to solve this by squaring both sides. So this square and the square root will undo each other, and over here I just get back to x minus 4. Now be careful here, this is not x squared minus 1 squared. This is x minus 1 times x minus 1. So I'm going to have x squared minus x, so minus 2x, and then plus 1. Now I need to get everything on one side of the equation. So again, I'm going to add 4 to both sides, and I'm going to subtract 4x from both sides. And so over here I'm going to have 0, and over here I'm going to have x squared, and then minus 2x minus 4x is minus 6x, and 1 plus 4 is 5. Now, I can get the solutions to this by factoring. That's quite an easy thing to factor. Two numbers that multiply together to give me positive 5, but add up together to give me negative 6. Well, negative 5 and negative 1. So I can factor this. Now I'm in a position to solve this for x. I can see if x is 1, it'll make the whole thing 0, and I can also see if x is 5, it'll make the whole thing 0. Now, not so fast. These might be, one or both of them could be extraneous. So we have to check. You must check. You must go back and check. So what happened in the original equation? So what happens if x is equal to 1? Then this becomes the square root of 4 times 1 minus 4 plus 1 minus 1. And what's that equal to? Well, that's the square root of 4 minus 4, which is square root of 0, which is 0. And then 1 minus 1 is 0. And so that is fine, yes. So we have an x-intercept at the point 1, 0. And what about 5? Check 5 into this equation and see if it works. Alright, so I'll get 20 minus 4, which is the square root of 16, and 1 minus 5 is negative 4, and I get 4 minus 4, and that does equal 0 as well. So that also works. So I have two x-intercepts, and they're these points, And were there any extraneous solutions for x? In this case, no, there were not. Okay. All right. Find any intersection points for f and g algebraically. Again, do not use a graphing calculator. And were there any extraneous solutions for x? Well, if there are, you won't be able to see them on a graphing calculator. Okay, so for intersection points, you put them equal to each other. So the formula for f is equal to the formula for g. And now I have a radical equation. And to solve this for x, I'm going to square both sides. So the square will undo this square root. And again, I'm going to have not x squared minus 3 squared. I'm going to have x minus 3 times x minus 3. So I'm going to have x squared minus 6x plus 9. And I need to get everything on one side again. So I'm going to add 4x to both sides. And I'm going to subtract 57 from both sides. Okay, so I'll have 0 is equal to x squared minus 2x, and 9 minus 57 is negative 48. Now, can I factor this? If you can't factor it, you can use quadratic formula. Two numbers that multiply together to give me negative 48, but add up together to give me negative 2, and negative 8 and positive 6. And the solutions for this equation are x is equal to 8 and x is equal to negative 6. So I have potential x coordinate of any intersection points, but I got to give the points. Now, before I do anything else, I need to check and see if they match the original equation. So what's the original equation here? The original equation was f of x, the formula for f of x is equal to the formula for g of x. Does 8 work? Let's check 8. So I'll have 57 minus 4 times 8. And what is that equal to? Is it equal to 8 minus 3? So 57 minus 48, no, 4 times 8 is 32, sorry. 57 minus 32 is 25. And 8 minus 3 is 5, and the square root of 25 is 5. So 8 is okay. And we do get an intersection point, but it's a point. We need an x coordinate and a y coordinate. And so I can pick either f or g. G's the easier formula. And if I plug 8 into the formula for g, I get 5. So 8, 5 is one intersection point for sure. Now, what about negative 6? Let's check this original equation with negative 6. Is that equal to that? And I'll have 57 plus 24. And is that going to be equal to negative 9? That's the square root of 81. Is that equal to negative 9? Well, no, it's not. The square root of 81 is positive 9. So what we have here is an extraneous solution. And so we cannot use it. So this question, were there any extraneous solutions for x? Yes. X is equal to negative 6 was an extraneous solution. And that ends the video.